Project 2.7, ISP.Medium, the SafeKit. This project is a custom-built Arduino-powered safe designed to lock and unlock using a 4-digit passcode through a keypad. The system is controlled by a servo motor and was entirely designed in Fusion 360 and then 3D printed. It can arm and disarm the locking mechanism using a servo and gives real-time feedback through the serial monitor. It also recognizes incorrect passcodes and prevents unauthorized access. Here is a demonstration of it working. We start by pressing equals to activate the system, then enter the correct passcode. Once we do that, access is granted, the servo rotates, and the safe is now unlocked. We now open the door. Now, let's arm it again. We enter the passcode again. Now the servo returns to the locked position and the safe is now secured. If we try an incorrect passcode, access is denied. The servo doesn't move, but the safe remains locked. Here's how the circuit is built. However, we first must understand what a servo motor is first. A servo motor is a small device that can precisely rotate to a specific angle, typically between 0 and 180 degrees. It works by using a control signal, PWM, sent from the microcontroller, which tells the servo what position to move to. Inside, it has a motor, gears, and a feedback sensor that constantly checks and adjusts its position for accurate movement. Even though the wiring is simple, here's the setup. The analog keypad is connected to analog pin A5 on the Arduino. It only needs one wire since it works off voltage levels. There's no complex wiring. The servo motor's signal wire is connected to pin 9. Power and ground from the Arduino go to the breadboards, and both the keypad and servo motor are powered from those. Now onto the code. First we include the servo library so we can control the servo motor, and then define key constants and variables, like the analog pin the keypad is connected to, the digital pin for the servo, and a 4-digit passcode. We also create arrays that define the threshold values for each key on the analog keypad and what character each value maps to. The getKey function reads analog values from the keypad using analog read and uses a thresholding system to figure out which key was pressed. This is necessary because the keypad is resistive. It gives different voltages for each key, not separate digital signals. In the loop function, the system first waits for the user to press the equals key. This acts as a start or enter passcode button. Once the equals is pressed, it begins accepting digits. Each digit the user presses gets stored in an array called input code. Once the 4 digits are entered, the program uses strcmp to check if they match the correct passcode. If the passcode is correct, the servo rotates either 0 or 90 degrees to unlock or lock, depending on the current state of the system. If it's wrong, it prints access denied to the serial monitor. To keep things stable, there are debounce delays so the keypad doesn't accidentally register the same key multiple times. There are also flags like servo moving to prevent the code from interfering with the servo while it's rotating, and debug messages to help you monitor inputs in the serial monitor while testing. Now let's talk about the design. The case was modeled in Fusion 360. This design took many prototypes to figure out what type of hinge system needed to be used. It was designed with a pin-style hinge for the door instead of a snap hinge because it's stronger and smoother when opening and closing. I intentionally left the roof open for 2 reasons: to save filament as this large safe was on the limit, and to make it easier to see the electronics inside when presenting it. Inside, there's a mount for the servo that aligns with the locking arm connected to the door. The electronics fit neatly along inside, and I made sure that the walls were thick enough to be sturdy but efficient to print. On the side, there is a hole for the keypad, as well as a securing so it holds in place. On the door, there's a hook where the servo locks into, and on the door itself, there's a handle to open and close the door. In the end, this project is a fully functional safe and does exactly what it needs to do. This is Project 2.7 ISP.Medium, the SafeKit. Thank you for watching.